Okay, so here I'm going to make a video kind of making similar examples to the ones from the homework, and maybe that'll kind of help you out a little bit, and just let me know if you have any other questions. So this first one, it says find the vector with the given information. So what they're going to do is they give us the magnitude and they give us the angle right here. And they're going to want the answer in the unit vector form, which is AI plus B J, and so the I and the J just stand for the unit vectors. And so we have to find those, basically my x distance and my y distance, which is the A and the B part. So I know the complete distance of the vector right here is 12, and so it might help to draw a picture so we can have a little better idea of what's going on. So we're at 300 degrees, and so my vectors probably look something like that right there. So we know my x value is going to be positive and my y value should be negative. And so the way I'm going to figure out those x and y values is I basically want to use my unit circle to figure out that angle right there for the x and the y value right there. And then what I'm going to do is then multiply the magnitude by that. And so let me see. So over here, let's see. So we're going to do 12 times, and then let's see, the x value for at 300 degrees, like I said, if you look on the unit circle, that should be positive 1/2, so that would be 12 times 1/2, and then um, times I for my unit vector, and then plus, and then let's see, my y value for my from my unit circle here would be negative square root of 3 over 2. Oops, and I need to multiply that by 12. Well, it doesn't matter which one goes first. I'll multiply the 12 there. And then times my j. And then all I have to do is just kind of simplify this. So right here, the half of 12 would be 6i, and then this, the plus and the negative right here, this will become a minus, and then the 2 will cancel or reduce with the 12 down to a 6, and so I should be left with 6 square root of 3j. And so that is the vector from the given information. So they gave me they gave me the magnitude, so you multiply that by the magnitude, and then the other value you get from the direction, the angle that's created at 300 degrees. And so at 300 degrees, my x value from my unit circle would be positive 1/2, and then the y value was negative square root of 3 over 2. So you'll do the same thing, but you're going to use 120 degrees. So you're actually going to be up here. And so once again, you'll have to figure out the x value and the y value from your unit circle, and then just multiply that by 14, and then put that with the I and the j. Okay, let's see. Let's move on. So 4, okay, question 4 is actually basically the same as question 1. They just gave you the information in a different format. So I know you got question 1 correct already, but basically what you want to do is just kind of review this real quick. You want to take the tangent inverse of the y value over the x value. Now in this case, I mean, this is my a and b, but it's basically my x and y value for my vector, and so you're just going to take the ratio of those. Now, they're both negative, so it's going to end up being a positive. So you just need to take the tangent inverse of the b value over the a value. And just be careful, because when you put it in the calculator, it might not give you what you're expecting, because you might want to draw a picture and kind of have an idea of where this is at. So this is negative 693 units left, and then a little over 56 units down. So just know that you're in the third quadrant, and so that angle should be somewhere past 180. You know, it should probably be close to 200. I don't know exactly what it is, but it's going to be somewhere in the 200 range. And so when you put that in the calculator, it might actually give you something in quadrant 1, and you're going to have to add 180 to it, most likely. Um, okay, moving on. See, question 5. This one says find vector v plus vector w. They want us to use the unit vector format here. Okay, so what I am going to do is I'm going to pick out two similar vectors to what we're looking at here. So let's see, I'm going to pick, let's see, why don't we pick, I'm going to pick vector v and vector t. And what I'm going to do is I'm going to add those together just to give you another example. So vector v plus vector t. Okay, so what you have to do is, I mean, I could put it in unit vector form. I guess that might be easiest. And so my vector v right here, what you want to do is figure out this is my initial point. That's my terminal where the arrow's at. And so initially I went in the positive, I went positive 2 units this way. So my first value would be 2i. And then I went 3 units up in the positive direction, so that'd be plus 3j. So that is for vector v right there. Then I'm going to add that with vector t in my example, so plus, and then vector t, when I look at that one, what's happening is my x value is actually decreasing by 2. So that's going to be a negative 2i. And then my y value, I'm sorry, I got that backwards. I'm sorry, let me fix that. Sorry, I probably just confused you. My bad. I went the wrong direction. All right. So to get from here to here, let's see, my x value increased. I'm sorry, my x value increased by 4, so that'd be 4i. And then I dropped, there we go. Then I dropped 2 units, and so my y value, or my unit vector here, is going to decrease by 2, so I'm going to put minus 2j. So sorry about any confusion there. Then once I have that, now I'm ready to go ahead and combine my like terms. So my unit vector for I right here, I add that together, so that'd be a total of 6i. And then let's see, we have plus 3j and minus 2j, so that would simplify to a positive 1j. So plus, you can put a 1 in front, but it's not really necessary. Just put plus j, and there we go. So that was adding these two vectors together. And it didn't matter what order I added them. You know, you could add, I could have put the t vector down first and then the v vector and added them. But that's all I did. So I look at my initial point, and then to get from here to my terminal point, my x value increased by 4, my y value decreased by 2. So that's how you find the unit vector form. And so you find that for both vectors and then add them together. All right. Our next one here, okay, so question 6 and 8 are actually kind of similar. Like, in order to answer question 8, you have to know how to do question 6 in order to kind of set up your vectors. And the difference with question 8 is you kind of go a step further and you find the resultant vector. And so I have an example down here that encompasses all that. So we'll get to see kind of all those parts together. Okay, so this example here, so it says an airplane has an airspeed of 600 kilometers per hour with a bearing of 30 degrees east of south. Okay, so what we need to do is first come up with our vector for the airplane, and then what happens is we have the wind. The wind is going to be going to cause the airplane to kind of go off a little bit from that direction, and what we'll do is we'll find the two vectors, and then we're going to add them together. So this is going to be the magnitude for the airplane right here. The magnitude is how fast it's flying, right? So let's see, we'll call this vector u or whatever. So my magnitude for this one is 600. And then the direction, now you have to be a little careful on this. Sometimes the wording can be a little confusing. So the bearing is 30 degrees east of south. So here's north, oops. So here's north, east, south, and west, right? So 30 degrees east of south. So if you're looking south, you're going to turn 30 degrees to the east. You're going to turn 30 degrees to the east. So that's 30 degrees. So 30 degrees east of south, okay? And so the way this is going to work, the way the vector I'm going to use, we always want to go from the x-axis to positive x-axis. So this is going to end up being 300 degrees is going to be the angle I'm going to use for finding my vector for my airplane. And so I have enough information actually to go ahead and figure this out now. And so what I'm going to have here is, so for vector u, my airplane, oh yeah, I gotta figure out the that 300 degrees is going to help me. Well, there's actually two different ways I could do this. You can use the um, the unit circle. Let me look at these if these were nice or not. Okay, these angles are not nice, so they're going to use the calculator. So that's the way I'm going to do it, just so I can show you. By the way, for that first question, question number 6, what they're wanting you to do is take this, and what you would do is you'd write, 600 times cosine of the angle that we found out, which is 300. Okay, so don't use the 30 degrees. You have to use the 300, and then and then plus, let's see, then we're going to have 600 times the sine of 300 degrees, and then that'll be my J. So that's kind of the question that they're asking on number uh, number 6, I believe that was. But then number 8, they want you to take it a step further. They want you to find the vector for the wind, and then what you do is we're going to add them together, and then once we add them together, we are going to use the calculator because the angles, we're not going to be able to do that without using the calculator, and so I'll show you how to do that in just a second. Let's go ahead and figure out the vector for the wind. Um, okay, so our wind, we'll call that vector W, I guess. So this will be our we'll call that. So let's see. So my velocity of the wind is 40, so that's going to be my magnitude. And then the angle direction is 45 degrees west of north. And so let's once again maybe draw in a picture will kind of help us here a little bit. So um, so facing west, so 45 degrees, oh, west of north. So if you're facing north, it's gonna be 45 degrees tilted to the west. So that's that angle right there that they're telling us. So 45 degrees west of north. So if you're looking north, 45 degrees to the west. So that angle that we're going to use here will be 135 degrees. So then our wind vector, I'm going to go ahead and put it actually below the, well, no, I'll just put it right here. So let's see, our wind vector is going to be 40 times the cosine of, and we're going to use 135 degrees, and then then plus 40 times sine of 135 degrees, and then J. Okay, so what we're going to do next is I have my two vectors, and so I want to figure out the resultant vector, and so simply you just add them together. Now, it is going to get a little messy, and so let me see, where's my calculator? Let me find that. Okay, so I got my calculator, and I believe they want it like a couple decimal points, so we kind of need to be careful. And so what we're going to do, we're adding the two vectors together, so I need to figure out, well, first of all, let me make sure I'm in degrees. Okay, good, I'm in degrees. And so here I go. So I'm going to do 600 times the cosine of 300. And so that'll give me this value, which actually this is coming out nice. I believe on the homework they're going to be decimals, but let me go ahead and write that down. And so we might get, I think I'll get some decimals on this next one. So then let's see, then plus, then I got to do it for sine. And so let's see, so second, enter, I got to change that to a sine. So then sine, and so let's see, there we go, there's a decimal. And so you do want to be a little careful here to make sure, I'm going to round 3 spots just to be safe. I think on the homework it's 2 spots. So let's see, negative 519, 615. Okay, so that is my y component of the vector of the plane. And then let me just double check. Okay, I got everything written down right. Okay, so now I got to do the same thing for the wind vector. So for the wind vector, let's see, it's going to be 40 times cosine of 135. And so let's see, it's going to be negative 28.284. Okay, and then plus, let's see, now I got to figure out the y value for that vector. So second enter, change the cosine to a sine. Here we go. And so let's see, that value is, okay, so yeah, that makes sense. All right, so then it's just positive though, so it's gonna be 28.284J. Okay, so then the last thing we want to do is we're actually adding the vectors together. So I just need to add the 300 with the negative 28.284 and then add the y values together also, and then that will be the resultant vector of basically where the plane is going to be headed. And then there are some extra questions about the ground speed of the plane and what's the direction. That's not going to be asked in the homework, so you're going to be okay there. But if you want to see it, let me know, and we can always work it out. All right, but I'm going to go ahead and just add these together real quick. So let's see, we're going to have 300, and then plus negative 28.284. So 271,716. Okay, so that's going to be my unit vector for my x component right there. So that's good. And then now I need to add the y values together. So let's see. That would be, I believe it's negative 519.615. And then we're going to add a positive 28.284. And then press enter. So negative 491,331. And then, so there we go. So that would be the resultant vector right there, the combination of the plane flying. So you can see the plane's flying like this. The wind, you're actually basically kind of flying into the wind. It's pushing you a little bit off course. And so that's what happens there. And so you can see that that wind is causing my x and y values of the original plane vector to decrease because it's pushing against me, so I'm not flying as fast as I was. So if I were to find the magnitude of this, it actually probably wouldn't be 600 because I'm getting pushed backwards as I'm flying. So we're flying into the wind, and so that's kind of what happened there. It's pushing me a little bit off course, but mostly I'm flying into the wind. So anyways, that's what they're looking for right here on this one right here. So you'll do it the same way. It's not a plane problem, but they just give you two vectors, and so one's going at 175 degrees, and then the other one's going at 230 degrees. So that'll be a little bit easier. You don't even have to find the angles. They just give them to you. But it's going to be set up the same way, how you want to come up with the two vectors, and then you're just going to add the two vectors together, and that's going to be the resultant vector. Okay, let's see. I think we got two more. Let's see, right here it says find the magnitude of this vector, and so I have an example right here. Magnitude's actually pretty simple. That's just distance. And so there is a formula for that. And so really, I mean, I guess I could give you a picture, but I'll also kind of give you the formula. So this is our A and B component value of our vector right here. And so what's going on is we're going, let's see, over 2, down 5. So we're going over 2, down 5. So you're basically looking for the magnitude of this vector where I'm going over 2 spots and then down 5. So really you're just doing Pythagorean theorem to figure this out. So in order to figure out the magnitude of this vector, it's just going to be the square root of a squared plus b squared in terms of the values of your vector. So we're just going to have 2 squared plus negative 5 squared. So we're going to get the square root of 4 plus 25, which is the square root of 29. And so that's the magnitude. So you'll do the same thing with your vector up here. Take those values, follow this formula, and you should be in good shape. All right, let's see. What do we have next? I think, okay, we got a couple left. So Um, Here on number 9, so right here it says the vector v has the initial points p and the terminal point q. Write the vector v in component form that has, that is, find the position vector, and then write your answer in the unit vector form. And so, yeah, this isn't too bad. So, the component form basically just tells you what was the change in your x value and the change in your y value, from your initial point to your terminal point. So we are going to do that, but I'm going to do it with this example down below so you can have a different one. And once again, drawing a picture can sometimes help give students a little bit better understanding. So let's see, my initial point is over 9 down 7, so there's a rough sketch. So about right here, I'm at 9, 7, and then my terminal point is over, oh, I'm sorry, I went, sorry, I went in the wrong direction. Actually, you know what? Hold on one sec. Okay, sorry about that. I actually went and grabbed a different problem because I wanted one of them to at least have a negative, because your example has negatives, and so I want to make sure we kind of address that. Okay, so I'm actually using a different problem. So over 3 up 6, and by the way, there we go. Now I'm in the right spot. So my initial point right here is at 3, 6, and then my terminal point is at negative 3 up 4. So negative 3 up 4, about right here. So, and so there is q, and we're at negative 3, 4. And so my vector is starting here and it terminates right there. Okay, so to find the component form, it's pretty simple. You just you have to figure out, like, you take your resultant vector and subtract the initial point, for the x value. So this would be basically, let's see, so this would be like x1, y1, and this will be x2, y2. So for my vector, what you want to do is you want to find x2 and take away x1 so you can figure out how did x change. And then same thing with the y values. You're going to take y2 and subtract y1 from it, okay? And it's very important that you go in that order. So the resultant, I'm sorry, the terminal point coordinate value goes first. So for this one, it's going to be negative 3 minus 3 for my x. And then for the y's, it's going to be 4 take away 6. And so we're going to end up with negative 6 and negative 2. And so that is the component form of that vector. Now, just kind of look at the picture. That hopefully that makes sense, because my x value went from being positive 3 to negative 3. So my x value decreased by 6, right? So there's a change of negative 6. And the y value went from being positive 6 to positive 4. So that decreased by 2. And so that is the component form of the vector. And then the unit vector form is pretty simple. Those are the coefficients of the unit vector I. Well, you could put plus, but I'm going to put minus. You could put plus and negative, but I'm going to put minus 2j. It's a little bit more simplified like that. Okay, so um, that is, for example, our question 9. So hopefully that helps you there. And let's see, I believe, do we have one more? Okay, one more. So right here it says find the unit vector in the direction of this vector right here. So they want us to find the unit vector. Okay. So what we're doing basically, I'm going to use one of these problems down here though, so that you can do your own in a minute. Basically, this would be the same thing. I'm going to focus on number 8. This is the same thing as let me put it in unit vector form. This is the same thing as 6i minus 8j. Okay, and so actually, you know what? I'm sorry. I changed it on you. I'm going to do the other one, and the reason why is because the magnitude isn't as nice. I want to pick one where the magnitude, because I know it's not going to be clean on yours. Okay, so this vector v, this would be 2i minus 1j or whatever. And so all you do, this is pretty simple. You just have to find the magnitude of vector v, and then you just divide both of your component values, the I and the j, by the magnitude. And that's it. that's all you have to do. So the magnitude, if you remember, the formula is just the square root of a squared plus b squared, and then you take the square root, and that will give you the magnitude of the whole vector. And then what that does is when you divide both parts of it by the magnitude, it shrinks it down to a unit vector, to where that distance of the vector is only 1 unit long. So that's what we're trying to accomplish here. So let's see, we're going to have the square root of 2 squared plus negative 1 squared. So we're going to get the square root of 5. I'm sorry, I'm getting to my answer already. Let's see, so square root of 4 plus 1. And so 4 plus 1, so the square root of 5 is the magnitude. And then all you have to do here is divide both parts by that. So my vector is going to be 2 divided by the square root of 5i minus 1 over the square root of 5j. And so that is a unit vector. And what that means is that the distance of this vector is 1 unit long. And the way we did that was because we found the distance of the whole vector and divided it by that. And then it turns that into a vector that's 1 unit long. Okay, I hope that helps. And if you have any further questions, just let me know.